So today the DS Incubator will be covering debugging with targets. There are three sections or subsections in the chapter debugging in the targets manual, and I think the most important one is the first one, for users at least, of medium-sized pipelines. So that's the one that I would like to cover today. And then maybe we're gonna cover the third one. Not very sure if we're gonna have time for the second one. So we're gonna be talking about basically the idea of debugging. When something goes wrong and you need to find where the problem is to fix it, there are some tools that you can use normally outside a pipeline and in a pipeline. So, but the two approaches are a little bit different. So let me show you first what we mean by debugging. I guess that we are all familiar with the term, but the tools may not be very familiar, because most of the time we just debug by printing things on the console and seeing what we get. So that's the approach that we most of the time have to fixing problems. But there are tools that we can use, and we have covered those in DS Incubator meetups before. I think Jackson covered one or two meetups on that topic. But just as a very quick overview, so here I am in R. For a moment, forget about targets. Let's just talk about the idea of debugging. So say that I have a function here called add1. This function takes an element and adds 1. And then I have another function that takes an object and applies the function add1 first and then multiplies that times 2. So I could run this. First, I'm gonna run these lines from 1 to 6 to basically put that on my environment. So you can see now that at the very bottom here in my environment, I have the function add1 and the function calculate. Sorry, what did I do there? There we go. So I mean, if I give a sensible value to x here, and then I feed, so say that I feed it with the number 1. Let's make this a little bigger. So now this should work fine. So calculate will do what I expect it to do. So for example, it returns the value 4, right? Because I fed the value 1, but then 1 was added to 1, that makes 2, and then was multiplied by 2, that makes 4, right? So that's good, no problem with that. But then what happens if for some reason x becomes the string 1 instead of the value 1? Let's see what that happens there. Okay, so if 1 instead of being a double or an integer is a string, then when I feed it to calculate, I get an error. So you can see here in red to my right. Let's expand this a little bit. So how would I go about finding the problem? Well, one of the mainstream tools that we have in R is the traceback, which kind of shows us how we actually got to that point, to that error. So that's a very useful function because it points exactly where the error came from. It came from the function, not the one that I called, which is calculate, but instead from the function add1, and specifically it's telling me that it's in line 2. So here, if I go to the function add1, here, in line 2, that's pretty cool, right? Very precise, so we exactly know where the problem comes from, and then we could try, figuring out what was going on with that line. And it makes sense, right? Because if 1 is a string, R doesn't know how to sum the string 1 to the number 1, right? But there is even better tools. So now, now that we know where the problem comes from, so we know that comes from the function add1, we can use the function debug and pass it the symbol add1. So add1 is an object that lives in my environment, right? So let's review that here. So add1 is an object, so I can use a symbol as opposed to the string add1. So I run that function debug add1 because that's the function I want to debug. And then I do exactly what I did before, basically, to pass to call the function calculate with the value that I had passed before. And now something super interesting happens, that you see that we enter in this mode, which is a different mode. It's called a debugging environment, where my console now looks a little different. It has this browse thing. And also, this kind of file is open where the definition of the function add1 is available to me. And also I have here the traceback, something similar to what I showed you before. I could jump to different steps in the stack, it's called, in the stack of what, of functions that were called to the point where an error was thrown. But here is the point where we are interested, right, in add1. So now I can use these tools here, like for example, say next, or press the letter N and then enter to jump from the arguments into the body of the function. And if the function was long, say 10 lines, I could press N, enter 10 times and move along the body of the function. But one interesting thing is that we now have, as you can see, in this environment mode, in this debugging mode, we are inside the environment of the function. So we have access to the objects as they exist inside the body of the function. For example, the value x. So x is still a promise, it's called. So it hasn't been given a value yet. But as soon as I press x, x, I mean this value, if I want to query what is the value that x holds, that promise materializes into the value that it has. And now I can inspect exactly what the function is seeing when it runs. And interestingly, I realized that, oh, shoot, this is a string. This is not a double. So obviously I did something wrong there. So that's how, we debug. And we can go here and say, oh, shoot, I realized that this shouldn't have been a string. It should have been a double or an integer, right? So I can stop my debugger. I know already what it is. And now I can try again. And it now works. Oops, actually, it doesn't. What is that I did wrong? Maybe I need to restart my session to show this example. Because I didn't source the functions. Okay. There you go. So this is the expected behavior, right? Okay, so any questions so far? I mean, this is a brief overview of like normal debugging outside a pipeline for targets. Any comment or question there? Okay, take that as a no, and I'll move on. So sorry if this is like a repetition of something that you already know, but because we are going to be adding a layer of complexity now, I thought that it was important to make sure that we refresh the tools like debug and traceback that we have at our disposal. So now let's think of targets. So let's restart my session. Let's let's leave this here. I'm in a targets project. As you can see here, I have a targets folder, I have a targets file. It's not very important to look at the details of the file just now. Actually, it's the exact same file that we saw the last meetup. I haven't changed it except for a comment that is there. I'm going to show you in a moment. So let's say that we want to explore this pipeline. How do we go about that? So the first thing we do is we attach the targets package. And you know already that you can do target, for example, this network. This network gives you a very quick and nice overview of what the pipeline is like. So let's see. Okay, I see that since last time, let me kind of move things around a little bit. So this pipeline has a bunch of targets here to the left. They all somehow get a data set, right? Everything that is output here to the right somehow points to this data. So data is an object that is a data set that was first cleaned. There was a raw data, then it became a data set, and then that data set was used to produce a bunch of things, like to feed a linear model, to produce a report. This is a report. And these other two things too, which is this is another report that depends on this target that is broken. So this target called LM plot is broken, and therefore everything to the right of it is out of date, because with that target broken, everything downstream from there won't work. So we need to fix this target here, and we need to find where the problem is. So okay, we're gonna do debugging with the targets pipeline. So how do we go about that? So the first thing you would do is, we are in target, so tarmake is your friend. It will try to recompute things that that are described in the pipeline. So the pipeline here is here to the left. So this is a list of targets, and the ones that are more relevant to us are here. So let's see. We know that from the plot even, we know that the target that was broken was called LM plot, which is this target here. But let's see how that would be kind of exposed through a call to tarmake. So let's say that we want to again recompute the pipeline, and we see that it works all the way up to this point where we get an error. So targets is already giving us some information about what there is an error, and also where the error is. So it's in the target LM plot. So it is, we narrow down the problem of trying to find the bug to this specific target. Also, and very importantly, because debugging in targets is not exactly the same as debugging in vanilla R, importantly, we had a link to basically the manual. So that is something that I strongly recommend. So actually I'm going to be using this here to my to the left of my screen to follow actually the steps that the manual recommends. So basically it is a link to the chapter that we are talking about today. And as I read, I realized that there is a bunch of methods. There's 3 methods, and the one that I'm going to be covering today is the first one. Also, it's telling me that there is a function that is called tar meta that, it's a data frame that contains a bunch of information about targets, but in particular, we can explore the field error. So error is just a column in that data frame. As you can see, all we have done is just narrow down that data frame to the specific column that shows the errors and the name of the targets. And here we see that there was an error in this one target, right? So this is another view of where to find the problem first. So that's the very first place to start. I see. Was that a hand? Yeah, go ahead. Yeah, sure. It's showing the error message. So I wrote a very informative error message. It is an error that I injected, of course, on purpose for the demo. My error message was, oh no. Actually, I don't know. Maybe let's see what the names of. I'm not very sure. I haven't explored the format. So I'm reading what column names we have in the tar meta. That's something interesting to try to explore on our own time. Yeah. So how we could go about that now? Okay. So I'm again now reading. It looks like I'm looking at you, but actually I'm looking at the manual and reading the instructions. So we enter now this first mode of debugging that the manual proposes, which is called environment browser. So that's the experience that is the most similar to the one that I showed you when we are debugging in vanilla R. So the very first thing that the manual recommends is that we restart the session. So usually, you use targets because you are using expensive computations and you value what you have done a lot because it may have taken hours to produce. So, in the manual explains, how kind of restarting your session and before you actually start debugging can protect you from destroying targets that you care about, that you kind of, work hard to produce, to compute. So the first advice or guideline that is, the first thing we need to do is, of course, to use targets. So let's do library targets. I'm also going to source all functions in R. I did it in a very quick way, Shift Control L for me, because as I mentioned a couple of meetups ago, this project is not only a targets project, but it's also an R package. So that means that I have tools like DevTools Load All at my disposal with keyword shortcuts, which just pressing that keyword shortcut, it loads everything in my R folder. So everything is kind of ready to go. Now the manager says, okay, now what you do is you call debug, which is the same function that I showed you before when we were working with vanilla R. And now you call the function there, you ask to debug the function that produced the problem. And this is where we have to be a little clever, right? Because the targets told us that the broken target is this one, lm plot. But as you can see, that target is actually store is just a name, right? But the computation happens in the expression here in this command. So the command is the one that we want to debug. So the name that we need to inject there is plot lm, right? So what we want to debug is the function plot lm, which is, it may be different the name than the one that you get from the target pipeline. So I'm gonna run that. So now it's ready, the debugger to be kind of fired. So by the way, in 5 minutes I should stop. So I'm gonna nominate Jackson, because you just were kind enough to talk today, to kick me out of, of the meetup in 5 minutes, okay? So next step is to run tar make. So we did something very similar to what we did in vanilla R, right? And now we want to remake this pipeline. So we run tar make. But now we can be more specific. We can say, so tar make has an argument that's called names that allows me to say, okay, what is the target in which I want to focus? So again, think that we want to focus on this one specific place, and we want to save any potential extra computation that we don't need to do. So now what we put here is the name of the target. So the target that we want to make is lm plot. And it makes sense, right? So we are debugging the function or the command, the function that holds the command for this other target, right? But there is one more argument that we're gonna add here, and this is probably the most important part of the meetup. And this is the idea that targets run on a background process every time, and that's why it's hard to debug, because we don't have in our global environment the objects that that target has when it's computing things. And why is it difficult? Well, because if we want to explore what target is seeing, then how do we enter that environment? And that's what we're gonna do now. So what we're gonna do is we're gonna bring that process that usually runs at the background, we're gonna bring it here to the foreground so we can play with it. So the argument is called call R, because there is a package that is the engine of that process. It's called R function. Usually there is a function that runs to move the process to the background, but now we're gonna say null. So don't move it anywhere, just kind of bring it to me. I think that's all I need to do. And when I did that, and now I'm back to the familiar debugging environment. So as you can see, R automatically opened this file because I have the source code. The file is called plot_lm. It has the function called plot_lm. And I can use the next and things here. Let's press next, and it moves from the line 11 to line 12. I can now query, I can do again next if I want. Let's click here again, next. So now that I have, I'm in line 13, so that means that I can ask for, okay, so what is ozone? Okay, it's null, right? Because it is assigned here, right? And I have also, okay, what is data? Okay, data is a data frame, I can inspect it, and so on and so forth. Right, so that's the process. So now we are inside the function I want to debug, and I keep either pressing next here or entering n until I reach the point that I want to debug. So here is the problem that I have discovered. Oh no. So obviously I forgot to remove this line, right? And that is what's gonna fix the problem. Because I'm in a package, I need to rebuild the package. Now that I have removed, I changed the source code of another package basically. So I'm installing the package again. So now with that done, I can restart my session, use targets again, and now do tar make. And that should complete with no trouble. So as you can see, the targets that everything was kept except for the targets that were broken before, which is this one, lmplot, and now it works fine. I could do a tar this network, and now remember that there was a broken target there. Well, now I expect it to no longer be broken. Let's see, I think I have it somewhere. Here it is. So let's expand this and show it to you. Okay, so remember this target was broken before, now it's not, right? So that wraps up the meetup. The problem that what we haven't covered actually is these other two ways of debugging. Let me show you what those are. So the debug option is very similar to what we did. It's just that you set things up not kind of interactively on the console as I did, but you do it on the _targets.r file, which is kind of the main targets file. And then workspaces has a benefit and a downside. The benefit is that it's persistent. So if you if you want to retrieve all the dependencies of the target that has the problem, workspaces will do that for you. It is a best fit for situations where your pipeline is super complex and that you just want to see the whole picture. It's not so much for interactive work. The downside is that you don't get a debugger mode. All the things that you get is just the targets that depend on the problematic target, but you don't get a view inside the body of the functions that produce that target. Anyway, it's good for you to know where to look for the information when you need it. So with this, I'm here at 25 past, so I'm gonna stop here and open the room for a quick round of voices. First, actually, let's do the questions and comments as a round of voices. So the first in my list here is Antoine. Antoine, would you like to comment or ask something? Thank you. Thanks a lot. CJ? Yeah. Yeah, actually, the thing that I forgot to mention actually is why you would do all this hassle. Let me stop here this function again and install the package. So I'm back to where I was before. What I want to show you is why the normal mainstream tools don't work. So let me do library targets and tar make. So the problem with why we need this extra layer of tooling is because the normal tools won't work. So if I do, I have just run a pipeline and it doesn't work, there is an error. So if I do traceback here, the traceback that I get is not as neat as the one that I showed you before, right? You see, it's very complex and it deals with a lot of low-level details that are not pointing me in the right direction. So that's why actually we need extra tools as opposed to just like the normal traceback that I show you here, right? So for some reason your comment, CJ, reminded me that I forgot to show why the normal tooling fails with targets. Any comment about that, or should I move to the next person? Claire? Cool, thanks. Jackson? I totally endorse that comment. So just one more time, Jackson gave a DS Incubator meetup about that. Also, it's very well documented in it because every IDE has its own debugger. So our studio has its own debugger, and it works pretty nice, as Jackson is suggesting. So also our studio website has basically like written and maybe videos as well about how to debug with our studio. And yeah, I think it's worthwhile your time 1,000 times. Jakob? Perfect. Yeah. Monica? Yeah. Yeah, that's true. Olga? Yeah. Sure. You're very welcome. Okay, so with this, we come to the end of this meetup. And again, my suggestion would be that it would be the end of the series because I noticed as I walk through the series how complex and powerful, right, Targets is. But the complexity also means that the meetups might not be very useful until you reach the point where you need them. So the next two topics that I have in mind are topics that are kind of at the level of depth way beyond what we've seen so far. And while I think they are important, I also think that they will become important only after you have kind of played with targets quite a bit. So I won't make a decision like right now. I will kind of consult you on Slack before I make such a strong decision to stop now and to give the two other topics that I'm thinking about. But just leave you thinking, so you can expect me to reach out to you in the next couple of days. And also, if you have interest in meetups, in delivering meetups next Tuesday and the one following that one, let me know. With that, I thank you very much, and I see you next time. Ciao, ciao.